In this presentation, we are going to learn about the legal implications of the operating system. Before further ado, I'll introduce myself. I'm a student currently pursuing bachelor's degree at IARE in data science. I'm from section B. Now, what are the objectives of this presentation? That would be first introduction to the operating system, its general history, uh, components, like that. Next, what are the legal implications of the operating system? So, let's start with the introduction. Computer, an operating system is an interface between a computer user and a computer hardware. An operating system is a software that performs all basic tasks like file management, memory management, process management, handling input and output, and controlling peripheral devices such as disk drives and printers. Generally, a computer system consists of the following components. Computer users are the users who use the overall computer system. Applications of software that application software that is a software that users use directly to perform different activities. This software is simple and easy to use, like browsers, Word, Excel, different editors, games, etc. These are usually written in high-level languages such as Python, Java, and C++. System software are the software that is more complex in nature and they are nearer to computer hardware. This software are usually written in low-level languages like assembly language and includes operating system in them, such as Windows, Mac OS, Linux, etc. Now, computer hardware includes monitor, keyboard, CPU, disk, memory, etc. If we consider computer hardware is the body of the computer system, then we can say operating system is its soul, which brings it alive, that is operational. We can never use a computer system if it does not have an operating system installed on it. So, what are the examples of the operating system? Well, first is Windows. This is one of the most popular commercial operating systems developed and marketed by the Microsoft. It has different versions in the market like Windows 8, Windows 10, etc. and most of them are paid versions, but right now there is certain leniency on it. Linux, this is a Unix-based and most loved operating system, first released on September 17, 1991 by Linus Torvalds. Today, it has 30 plus variants available in different distributions such as Fedora, Ubuntu, etc. Most of them are available free of charge to you can have their enterprise versions by paying a nominal license fee. macOS. This is again a kind of Unix operating system developed and marketed by Apple since 2001. iOS, on the other hand, is a mobile operating system created and developed by the Apple Inc. Exclusively for its mobile devices like iPhone and iPad. Android is a mobile operating system based on a modified version of the Linux kernel and other open source software designed primarily for touchscreen mobile devices such as smartphones and tablets. Some other old but popular operating systems include Solaris, VMS, etc. So, what are the functions of the operating system? See, these are the functions of the operating system, that is process management, input output device management, file management, network management, and so on. These functions are the basis of the operating system through which the user is performing his task. What is a brief like let's have a brief history about the operating systems. Now, the first operating system was created by the General Motors in 1956 to run a single IBM mainframe computer. Its name was IBM 704. IBM was the first computer manufacturer to develop operating systems and distribute them in its computers in the early 1960s. Operating systems have been evolving through the years from the 1950s. First, they were used to create calculators. Right now, they are doing tremendous things with using the operating system. But it had a very humble beginning, which were very expensive in nature. Now, there are few facts about the operating system evaluation, such as Stanford Research Institute developed the ON line system, that is NLS, in the late 1960s, which was the first operating system that resembled the desktop operating system we use today. Microsoft bought QDOS, that is Quick and Dirty Operating System, in 1981 and branded it as Microsoft Operating System. As of 1994, Microsoft had supported MS-DOS. Unix was developed in the mid-1960s by the Massachusetts Institute of Technology, AT&T, Bell Labs, and General Electric as a joint effort. Initially, it was named Multics, which stands for Multiplexed Operating System. Next, we have all the other examples as well. So, what were generations? Now, in operating system, briefly, there are four generations. So, let's have a brief look on them. In the zeroth generation, is used to refer to any period of development of computer when Charles Babbage invented the analytical engine and later John Atomsoft created a computer in 1940. The hardware component technology of this period was electronic vacuum tubes. These there was no operating system available for this generation of computers, and computer programs were written in machine language. The computer in this generation were inefficient and depending the varying competences of the individual programmer as the operator. The first generation marked the beginning of commercial computing, including the introduction of Eckert and Macaulay's UNIVAC in early 1951 and a bit later the IBM 701. System operations was performed with the help of expert operators and without the benefit of an operating system for a time, though programs began to be written in high-level procedure-oriented languages and thus operators' routine expanded. Later, the monoprogrammed operating system was developed which eliminated some of the human interventions in running jobs and provided programmers with a number of desirable functions. These systems still continue to operate under the control of a human operator who used to follow a number of steps to execute a program. Programming language like Fortran was developed by John W. Backus in 1956, which much prevalent during the first generation. The second generation of computer hardware was notably characterized by the transistors replacing the vacuum tubes as the hardware component technology. The first operating system, GMOS, was developed by the IBM computer in this generation. Now, GMOS was based on a single-stream batch processing system because it collects all similar groups in groups of batches and then submits the job to the operating system using a punch card to complete all jobs in a machine. The operating system is cleaned after completing one job and then continues to read and initiate the next job near punch card. Researchers began to experiment with multi-programming and multiprocessing in the computer services called the time-sharing system. A noteworthy example is the compatible time-sharing system developed at MIT during the early 1960s. The third generation officially began in April 1964 with IBM's announcement of its System 360 family of computers. Hardware technology began to use integrated circuits, which yield significant advantage in both speed and economy. Operating system development continued with the introduction and widespread adoption of multi-programming. The idea of taking full advantage of the computer's data channel input-output capabilities continued to develop. Another progress that led to the development of the personal computers in the fourth generation is the new development of mini-computers with the CPDP-1. The third generation was an exciting time indeed for the development of both computer hardware and accompanying operating system. The fourth generation is characterized by the appearance of the personal computer and the workstation. The component technology of the third generation was replaced by very large integrations. Many operating systems which we are using like Windows, Linux, Mac OS are developed in fourth generation. The following functions of the operating systems in the fourth generation are memory management, process management, device management, file management, security, control over system processes, etc. So let's have a quick look on the legal implications. Free versus open. While open refers to the right to use a set of specifications, free more narrowly refers to the right to use a single program. Linux being a very wonderful product of the legal system. its many technical attributes notwithstanding, perhaps its most significant benefit are its freedom from legal claims. While some have referred to Linux as open software, it is most important to distinguish between the terms free and open. Open is more often associated with open architecture, referring to a set of hardware or software specifications that anyone may use to develop products according to those specifications. Frequently, industry or government organizations produce open architecture to try to facilitate standardization and interoperability, while a free program typically comes with an unrestricted ability to use, copy, modify, and distribute the software without the fear of violating the author's intellectual property rights. In many cases, free means that the software is in the public domain, and in this sense refers to freedom from intellectual property claims rather than the absence of payment. Next, operating systems and copyrights. In 1976, the Copyright Act was amended to extend copyright protection to computer programs by defining a computer program as a set of statements or instructions to be used directly or indirectly in a computer in order to bring out about a certain result. Nevertheless, as recently as the early 1980s, many believed that certain categories of software, including operating systems, would not be protected under copyright law. Perhaps more than other types of software, operating systems are functional, residing at the computer's core, and per editor performing much of the heavy lifting transparent to the user. Because the copyright laws protect only the expressive non-functional aspects of software and other work of authorship, many believe that operating systems were too functional to fit under copyright laws. So in 1984, FSS began the GNU project to develop a complete system software that would be upwardly compatible with Unix. The GNU system travels with a hard G stands for GNU. GNU is not Unix. Is intended to be free. By free, FSF means users enjoy three specific freedoms: to copy the program and give it away, to modify the program by having full access to the source code, and to distribute any modified versions of the software. Free expressly does not refer to price. FSF and other distributions will gladly take your money for copies of the free software. So this is the distinction between the free. Now pattern concerns. Isn't always easy or possible to create software that is certain to be free of legal claims, because copyright infringement requires copying a non-infringing work can be produced simply by avoiding any access to other copyrighted software. Avoiding patent infringement is not so easy. One infringes a patent by making, using, offering for selling or selling a product that is within the scope of the patent's claims, regardless of whether there was any awareness of the patent. Worse yet, a patent may issue tomorrow from an application filed several years ago. A software that is free today may infringe a patent tomorrow. Thus, while it is possible to produce software that is free from copyright infringement, it is not always possible to create a software that is free from infringement. In another example, let's say Unis and IBM patents constitute roadblocks for the free software community. Unisys and IBM hold patents covering the LSW compression algorithm, which is used for making GIF files. Hence, to sell software capable of making GIF files requires a license. Consequently, FSF has been unable to create free software capable of making GIF files, since the ownership is being fought between the IBM and the Unisys. So, if a company has patented a technology, then it would be difficult for other companies to implement the same procedure. That is the major concern. As an operating system uses multiple functions, if any of these functions are patented by another organization, then it would be a tussle in the court to have a common ground. A conclusion. There are certain legal implications on operating system as long as they are not open source like Linux or don't threat to the security of individuals and countries. So, in this, when I was referring for this topic, I was able to understand that Linux is the software that is most robust in terms of its legal infringement footprint. That is, Linux is defined in such a way that one cannot sue Linux for a problem. Since it's open source and community driven, any problem that is called that has been present that is present in a Linux is the problem of the community but not the order or author of the Linux. So that's how I was able to understand the legal implications on various operating systems. Thank you for listening.